This video takes a closer look at the non-standard spring type in Spring Calculator Professional version 2. For those of you who use the previous version, the fundamentals of how the spring is defined are the same, but you'll find it's much more user-friendly now. You still enter wire diameter, coil diameter and pitch information at particular coil positions, but these are now shown in a single table. Let's start by designing a simple compression spring, parallel-sided and constant pitch. Let's say we know there are 8 coils and the ends are closed, so we can enter the coil positions 0, 1, 7 and 8. For the wire diameter and coil diameter, we only need to enter a new value where it changes, so for this simple spring we can just put numbers in the top row. The pitch data must be entered between every pair of coil positions, but can be entered as either pitch per coil or axial length of each section. Here we'll use a mixture of 4mm pitch and 50mm axial distance. You can see that after the spring is calculated, the axial distance is worked out from the pitch, and vice versa. Here's a quick look at the spring to show it's as we expect. Let's set a tip thickness of 50% to grind the ends. Now let's make the shape a little more interesting. By right-clicking on coil position 7, we can insert another point in the middle. By default, this takes a coil position halfway in between the 2 points either side and keeps the same pitch. But if we put a coil diameter of 30 in the centre, we can create a simple barrel shape. We also need to tell the diameter to reduce back down to 25 at the other end. One brand new feature for version 2 of the non-standard software is the visual editor. Here we can drag the red handles around to change the shape of the spring and see the data update in real time. Note that when I drag to the left end of the spring it goes grey, showing there's a problem. The red section shows that the wire is overlapping itself because the pitch is too small. I can get around this by ticking these 2 boxes to fix the pitch in each end coil, then only the other 2 sections will vary. Let's have a look at another example where we use a visual editor to get the loads we need. Here I'll enter a simple dual rate spring. The axial distance is the same in each active section, but because the number of coils is different, so is the pitch, which gives us a change in rate. Now I'm going to enter my working lengths, but also the target loads I want to achieve. You see these on the load length graph. Our first load is okay, but the second is way off. I'm going to alter the pitch between the 2 active sections to try and get close, remembering to fix the pitch in the end coils so they don't move when I drag the middle of the spring. Thank you for taking the time to watch this video, an introduction to the non-standard spring type in SCP version 2. If you'd like to check any of this out for yourself, get a free trial at ist.org.uk/free trial.